Hello everyone, it's Tito Tom and welcome to my class. For today's lesson is all about solving quadratic inequalities. Just a quick review. Quadratic inequality is an inequality containing a quadratic expression involving the symbols like less than, greater than, less than or equal to, and greater than or equal to. So as you write it in a quadratic inequality, we write it having the standard form of an equation, but this time it's an inequality. So we have ax squared plus bx plus c, and choosing one of the four inequality symbols here. So let's start with less than 0. And you could write still the same with the other three. So ax squared plus bx plus c is greater than 0. And we also have ax squared plus bx plus c is less than or equal to 0. And the last one would be ax squared plus bx plus c is greater than or equal to 0. Any of the four here satisfies our quadratic inequality because, again, their degree and expression is 2, as you can see here, 2, 2, 2, and 2. And we have our symbols of inequality here, which are these. Which means these are solutions of a quadratic equation. So we have solutions of ax squared plus bx plus c equals 0. Now, why is this called critical values? It is because when we are given a certain quadratic inequality, for example, let's have x squared plus 3x plus 2 is less than 0, we try to make it as a quadratic equation first. So let's turn this into x squared plus 3x plus 2 is equal to 0. Now let's have a diagram on the factors of 2. So we have it here. So 1 and 2, obviously, because 1 plus 2 is 3, which satisfies our bx. And using a lazy method, so we could just turn the opposite of each number. So the opposite of 1 is negative 1, and for 2 is negative 2. In the number line, we have it here. Let's have negative 2 and negative 1. So basically, the number between the two is, let's just put negative 1.5. Now, going back to our inequality here, we have x squared plus 3x plus 2 is less than 0. Again, we're talking about critical values, which are negative 2 here and negative 1. Critical values because if you are going to use either of the two, it won't satisfy the given inequality. So let x be 2. So we have here, negative 2. So you have negative 2 squared plus 3 times negative 2 plus 2 is less than 0. So let's see if this inequality would be less than 0 or not. Now, negative 2 squared is 4. For this one, we have 3 times negative 2 is negative 6 plus 2 is less than 0. Now, as you can see here, we have 4 minus 6 is negative 2, and plus negative 2, the answer is 0. But 0 is not less than itself. So that means negative 2 as a critical, you have here negative 2 as a critical value, or what do you call this? A value of an x is wrong. It doesn't satisfy the given inequality. So same thing with using negative 1. So let x be negative 1. So you have here negative 1 squared plus 3 times negative 1 plus 2 is less than 0. So you have here negative 1 squared is 1, and negative 1 times 3 is negative 3 plus 2 is less than 0. 1 minus 3 is negative 2 plus 2 is 0. But then again, 0 is not less than itself, so which means negative 2 and negative 1 do not satisfy the given inequality. Now, again, we go back to the number line. We have it here. So let's just make use of three numbers. The critical value here, we have negative 2 and negative 1. And let's use the middle number, which is negative 1.5. And by the way, as you can see here, it is just a less than symbol. It is not a less than or equal to. Now, if you can see here that it is just less than, so if we illustrate it in the number line, it would look like this. You could encircle, but it is empty. It is not shaded. So you do it like this. Now, Tito, what if we use Tito, what if we use x squared plus 3x plus 2 is less than or equal to 0? Then that is a different story. We could write it this time in a number line having negative 2, negative 1. Again, since this one here has an equality symbol, so instead of having an empty space for both critical values, this time they are shaded. Again, they are shaded this time because the inequality symbol is paired to an equality symbol compared to the first one. Anyway, let's erase this first to avoid confusion. So let's go back. Now, since we know that the critical values of the given inequality are negative 2 and negative 1, which means that we should never use the 2 because just like here, they don't satisfy the given inequality. So to check out things on what will work, we are going to try either the numbers between negative 2 and negative 1, or the numbers after negative 1, or the numbers after negative 2. So let's try first to make it safe here. So let's try just the numbers between negative 2 and negative 1. Anyway, if we get to deal on the concept of infinity, we could use a lot of numbers between negative and negative 1. But just to be safe, or to have the thing that is very obvious, we could just have the negative 1.5. So let x be negative 1.5. So we have here negative 1.5 squared plus 3 times negative 1.5 plus 2 is less than 0. Let's see. So I have it here, negative 1.5 squared is 2.25. 3 times negative 1.5 is negative 4.5 plus 2 is less than 0. So we have here 2.25 minus 4.5. So where am I first? Let's just add this simply. We have 2 plus 2.25 plus 2 is 4.25. 4.25 minus 4.5 is less than 0. Based on this, we could just have 4.25 minus 4.5, in which the answer is negative 4, which is negative 0.25, which is actually true, which is less than 0, which means that in the number line here, so let's go back. So we have negative 2 and negative 1 as our critical values. So again, this one here should not be shaded because we just use less than and not the inequality symbol of less than or equal to. And we have here a middle number. We have negative 1.5, which is again based here is actually correct. Now, just to be sure, let's just try numbers outside of negative 2, which is going to negative infinity, and the numbers going to positive infinity. So this one here is just a thing of checking, just to verify that if it is just only the middle numbers between negative 2 and negative 1, or probably the numbers outside the critical values. So let's just try let x be negative 3 per se. So negative 3 squared plus 3 times negative 3 plus 2 is less than 0. Negative 3 squared is 9 minus 3 times negative 3 is negative 9 plus 2 is less than 0. Base here, 9 minus 9 is 0 plus 2, and 2 is not equal to 0, which means the number less than negative 2 is or do not qualify or satisfy the given inequality. So just to check again, let's just try the numbers after negative 1. So let x be negative 1. So we have negative 1 squared plus 3 times negative 1 plus 2 is numbers greater than 1 are 0 and going to infinity. So let us try 0. So this one here should be 0. Be 0. So 0 squared plus 3 times 0 plus 2 is less than 0. So here we have 0 squared plus 3 times 0 is just 0. So 2 is less than 0, which means that this is wrong. So the only numbers that satisfy the given inequality are the numbers between negative 2 and negative 1. So in an interval notation, we could write it like this. So we have here 2 and negative 2 and 1. Now, since again the inequality symbol that we just use is just the less than, we're going to use an open and close parenthesis. Okay, so we have it here. Okay, open and close parenthesis, which only means that the numbers will not touch negative 2 or will exclude negative 2, so as with the negative 1. It will not touch or include negative 1. And it only means that all the numbers between the two are included. So we have negative 1.9 and stuff that are going on in between. Okay, so when we answer it in an interval notation, it could be like this. So let me just write it again properly. So again, we have negative 2 and negative 1. Again, this is written in an interval notation. You could also write this one in an inequality form. So inequality form. So we know again that our variable being used is x, and let's have again the number line here. We have negative 1, negative 2, and numbers in between. Let's just say negative 1.5. And again, negative 2 and negative 1 are critical values, which means they are not included. Now going back to our given quadratic inequality, which is x squared plus 3x plus 2 is less than 0. As you can see here, we just used the less than symbol. So when you write it in an inequality form, we get to use here x is less than negative 2, obviously, and x is less than negative 1. So we read this as x is greater than -2 but less than -1. So we have the two answers in inequality form and also in an interval notation. And that's it for the first example. With less than or equal to 0. So let's just have x squared plus 6x plus 8 is less than or equal to 0. Again, this is different this time because there are now two involved symbols, the less than and the equal to. So again, find the critical values for this. So let's turn this into a quadratic equation first. So 6x plus 8 is equal to 0. So we have 8, so the possible values of 8 that could lead to 6 are 4 and 2. Because 4 plus 2 is 6. So we have it here. So lazy method. So just the opposite of 4 and 2, which are -4 and -2. Again, these are critical values. Now going back to the number line, so we have here, let's have -4 and -2. So the number in between them is -3 and other decimal points. Now, as you can see, we have used less than or equal to, which means our critical value here are actually included because we now have an equated version of it. So this time, if we encircle both critical values, since we have a less than or equal to, they are now included and they should be shaded this time. Earlier, for the first example, it is just encircled but empty. But for this one, they are included and shaded this time. Yeah, so if we try to use the -4 and -2 for our given quadratic inequality, so let x be -4. So we have -4 squared plus 6 times -4 plus 8 is less than or equal to 0. So 4 squared is 16. This one is 6 times -4 is -24 plus 8 is less than or equal to 0. 16 plus 8 is 24. So 24 minus 24 is less than or equal to 0, in which the result for this one is 0 is less than or equal to 0 or equal to itself, which means that -4 being used is correct. So let's also check for -2 to see if it satisfies. So let x be -2. So you have here -2 squared plus 6 times -2 plus 8 is less than or equal to 0. So here we have -2 squared is 4, 6 times -2 is -12 plus 8. So 4 plus 8 is 12, and just use the minus 12 here. So 12 minus 12 is 0, and 0 is less than or equal to itself, so which means -4 and -2 are correct. Now, let's write the number line again. So we have here -4 and -2, and the number in between is -3. So let's shade this one. So the numbers before -4 are -5 going to infinity, and the numbers after -2 are -1 going to infinity. To check on which numbers are included or satisfy the given inequality, let's check the in between or the before or probably the after. Just to check, and like I always say, it is better to try the number or numbers in between the critical values. So let's have negative 3. So let x be negative 3. So we have it here, negative 3 squared plus 6 times negative 3 plus 8 is less than or equal to 0. So negative 3 squared is 9. 6 times negative 3 is negative 18 plus 8 is less than or equal to 0. Now, negative 9 minus 18 is negative 9 plus 8 is less than 0, and negative 9 plus 8 is negative 1, which is actually true because negative 1 is less than 0, which means the number or numbers in between the number or numbers in between, let's have another color, in between negative 4, the number or numbers in between negative 4 and 2 here are actually correct. However, just to check things, let's try the numbers before negative 4 and the numbers after negative 2. So let x be negative 5. So negative 5 squared plus 6 times negative 5 plus 8 is less than or equal to 0. Okay, so negative 5 squared is 25. This one is negative 30 plus 8 is less than or equal to 0. Now 25 minus 30 is negative 5. Negative 5 plus 8 here. So negative 5 plus 8 is 3, which is less than or equal to 0. However, this is not true, which means the numbers before negative 4, which are the numbers negative 4.1 going to negative infinity, are wrong. Same thing with the numbers after negative 2. So let's try let x be negative 1. So you have negative 1 squared plus 6 times negative 1 plus 8. We have here negative 1 squared is 1. 6 times negative 1 is negative 6 plus 8 is less than or equal to 0. Now, 1 minus 6 is, we have negative 5 plus 8 less than 0. So negative 5 plus 8 is 3, which is not less than or equal to 0, which means this is wrong. Now, writing this in an interval notation would look like this. Earlier, in our given example, the inequality symbol that was used was just this. That is why we just use the open and close parentheses. But this time, for the second example, we use less than or equal to. So since we have an equal to here, and also the negative 4 and negative 2 both satisfy the given quadratic inequality, so we're going to use brackets. Okay, open and close brackets. Again, this only apply to having the equality symbol here. But if it's only limited to less than or the greater than symbols, then we should use only the parentheses. Anyway, so we have proven from the number line that the numbers negative 4 and negative 2 and the numbers in between them are true or satisfy the given quadratic inequality. So it is from here to here. Then we can write it as like this. Open bracket, which is negative 4 and negative 2 and close bracket. So this one here is your answer when you write it in an interval notation. And if we're going to write it in an inequality form, we'll get to have, again, use x, but this time we're gonna use the less than or equal to, because this was the given from the quadratic inequality. So we have it here, x is less than, x is greater than or equal to -4, but x is less than or equal to -2.